So great being here. Very happy to see everyone. And we'll be introducing Vega integrations in OpenSearch. I'm Lior Perry. I've joined OpenSearch about 2.5 years ago. I'm mainly focused on the open telemetry and observability, and that is something of a passion of mine. I'm working in the data domain, and thinking about schema and knowledge graphs is something that I'm very into. And this session will discuss this as well. And Aparna?
Thanks, Lior. My name is Aparna Sundar. I'm a researcher at OpenSearch. And Lior and I've been with OpenSearch for around 2 years. We kind of are very excited to introduce this. I do research with users to help UX, to help the team at large. So that's kind of my forte. I'm a cognitive scientist. That's my background. And we actually were very thrilled to put talk about this today because we started talking about dashboards and then looking in the future, looking at the best practices for our dashboards, OpenSearch dashboards users. This was a topic we came up with, and so we're very excited to present this to you today. We're going to cover a few things here. We'll start with some of the background and visualizations, very specifically with observability that we can use today, and then we'll actually cover some of the problems with OpenSearch, existing OpenSearch visuals and integrations there for developers. And then we'll go into what is Vega. Just quick show of hands. How many of you are familiar with Vega? Okay, so a couple of you here. Cool. All right, so this will be a very informative session for you. So we'll cover what Vega is. We'll then go into what you can do with Vega. And then Lior's going to actually give you a demo here. So Lior, go for it.
Okay, so first of all, we're focusing on the observability. And why is it important? Because observability is a key foundation of many of the things that we're doing in OpenSearch. And mainly we're focusing on understanding the system that we're observing. So observability is not only monitoring the system, it's also being able to remediate issues within the system, is being able to ask questions on how the system is behaving, is actually understanding the system without knowing the internal of the system. Think about it as an external observer, seeing effects, seeing data telemetry received from the system, and from these data points, understanding how is the system behaving, and after understanding and knowing the system behavior, acknowledge that there are incidents and issues that we need to remediate, so we need to investigate further. So being able to understand the system requires understanding the data. So understanding the data requires also to store the data and store the data efficiently so we can ask questions which are arbitrary. We don't know in advance how the system would behave, so we need to compose these questions as we go along, as we understand the system, and we need to use a very simple and very intuitive visual way to understand the system. And as Aparna mentioned earlier, the existing visualization that we have today are good. I'm not saying that they're not good, they're very good, but we need them to be better. We need them to have a better way of introducing these concepts as you go. The understanding the context and navigating through these problems is something essential. So why is observability complicated? So I'll just start by a question. How many of you are working on the observability domain and programming or on-call or site reliability engineers? So we have a few. And the modern observability components are not the simple ones that we learned about in university, the monolith programs that have a simple way of emitting logs and metrics. Today, a very simple application would have architecture that implies a very deep understanding of how the system is operating. Whether it's multiple service architecture or even architecture that implies that you have to have large scale, so you have to have multiple components that interact with one another. And this comes into the knowledge that these components are not made by the same vendor. That can be, as mentioned earlier, that can be open source, there can be multiple vendors, and they all interact with different protocols. So the complexity of understanding these types of systems grows rapidly. Adding to that, the capability of understanding the system is not only inflicted by the data points that we see, but we need to aggregate information. So we need to measure things along a trend and understand how the system is behaving along the time. So these complexities, which are inherent to every observability, and most of the modern tools have these complexities, requires us to have better toolings that can measure things, can understand things, and we can pivot from one point of view to the other while determining that the root cause and effect determine our system behavior. So just an example, a day in the life of the site reliability engineer. I wake up or something wakes me up in the night. There's an alert, there's an alarm. You go into the dashboard, you see a metrics. Now this metrics seems abnormal, something is not working correctly. So I need to understand, first of all, when the incident has occurred. So if that metrics shows early beginning time, it doesn't necessarily mean that this occurrence have occurred in that time. We need to correlate because as we just mentioned before, things can propagate from one service to the other, and the cause to effect may take more than that time that we measured. So we need to correlate different metrics to understand the actual time that this incident has occurred. So once that has been done and we have an assumption of the time frame, we need to dive deeper and we need to take the data points that compose of these metrics and start understanding, has this operation been started from one service or one component or one pod if it's a container, and understand what are the implications. So as this journey progress, we try to evaluate some hypotheses of what is going on, and to actually invest and understand or do the root cause analysis of this idea that we have of the system, we need tools that will supply us with these propagation and with these changes of the perspectives. And now we'll discuss of these tools.
Yeah, so now we're going to go into visualizations as such, the use of dashboards, the use of visuals. Like this all comes from talking to our customers. As you know, Lior mentioned before, you actually do have these trace analytics that take place. Our customers typically will see some kind of, fault, some kind of, alerts that gets them in. They need to figure out what's happening. So when you go into visualizations, you go into dashboards as such, you see our users will actually use these visuals, and it's not just showing a graph. What it is that storytelling. Actually, the data, when you look at it, there is some missing, something's gone wrong. They now need to get to that root cause analysis. And now these visuals actually help them recreate what's happening in reality. So very big kind of requirement for dashboards for our users are that there's a way to tell that story, the way that they can go back, analyze, see what's happening. Good visuals also help them with ease of understanding because they don't have to figure out, when you think about numeric information that's converted to visual information, it's actually helping them quickly understand what's happening without having to calculate what's happening. Think about, numerically, does it make sense? Or in terms of the traces, does it make sense? Things like that. Also, good visuals help eliminate a lot of noise. They're not seeing the information that they don't need to see. They're going into exactly what it is that they need to see, and then it highlights the useful information so people can kind of follow through, do what they need to do, ameliorate the problem, so on and so forth. And this is classic use case of observability. So we're going to just take a look at visualizations really quickly. If you think about data, it can be qualitative, quantitative. This is classic, like basics of data that we're looking at. And when you think about qualitative data, when it comes to dashboards and things like that, we have data that is descriptive or contextual. And this is really, it's really hard to see in numbers. So a good example is if you have zip codes, right? You can look at zip codes 98077, 98045, and it's all numeric. But then when you see it in graph format in a geospatial, things like that, that makes a whole lot of sense, and that's a different kind of meaning. So graphs kind of help with that. Visuals help with that. Our dashboards eventually will help with that as well. And then other examples are word clouds. The size of the word cloud kind of gives a different meaning. Users are able to use that more effectively, efficiently understand what's happening with that, and also heat maps as well. Moving on to slightly not linear, not data that's based on linearity and normality, just in between data that somewhat still based on numeric information, but very very simple kind of descriptives of pie charts, tables, metrics, gauges. So all this are visuals that users use. And finally, you're looking at, when you're looking at time series data or any data that can be looked at aggregate and statistically kind of made sense of, we have, everything discrete charts, histograms, scatter plots, linear information that's plotted out based on correlations, things like that. So if you think about what's the problem with existing OpenSearch visual components, firstly, there's limitations in terms of the queries that are single query. So basically, visualizing joins that are based on multiple index is kind of not possible. You have the graphs that are, or the visuals that are static and rigid, so it's always a single perspective. Not much animation going on. Animation kind of gives you that real-time feel of what's happening, and also no connectivity as such. More problems with our existing visual components are they're hard-coded with minimal configuration, and we need a visual descriptive language, which is why we are talking about Vega today, and Lior is going to go really deep into this now.
So this part was the introduction into Vega, and now we're actually diving into Vega and to understand how Vega can benefit us. So Vega is nothing new. It's been there from early days of even before the fork. Vega is a vocabulary that allows to extract data using queries. It allows to use the data and transform it into different types of results, to do map, to do aggregation, to do lookup. As Aparna mentioned, we can actually grab multiple indices data into multiple data sets within one visualization and do lookup and match data within the correlation of these different queries. They have enhanced capabilities to present data very visually and efficiently, meaning that we can present circles, lines, rectangles, and we can do combination of them to create very appealing, meaningful presentations and data flows. And they have interaction with the user. So I can move things, I can scroll, I can click and get a reaction. So it's very native to building a flow, a mechanism of things that are moving. And this is very essential for the part of the investigation and correlation that I mentioned earlier. We have to understand different point of view and continue gather that data. As mentioned before, we have to filter and downscale and understand what are the problems. So Vega, mentioning community, and we're very much for community. Vega is a long-term project that has a huge community adoption. It has a very long list of contributors. It has more than almost 1,100 stars in GitHub. It has rich library of example. It has supplementary of API and SDK libraries for Python, Altair, and for JavaScript. It has Vega Lite, so you can not only use Vega, which is JSON-based, as a direct, a direct language, but you can also use API to generate and construct that language very efficiently. So what can we do with Vega? So here we have just an example of the, there's no internet. So currently there's no connection to it, but Vega allows a very large library of examples. And these examples actually have a very long tutorial that can just copy-paste. There is an editor that allows the user to actually navigate through the different phases of the Vega and allow them to interact and build the component in that editor. So that editor really gives you a very clean and nice way to test your environment and really understand what's going on. And OpenSearch has invested, oh, here it is. So these are the really basic examples which cover many types of different analysis. You can see it has scatter plots, it has charts, it has distribution. It also has quality of information such as geographic maps or heat maps. It has animation, which is also very appealing. It can focus into a component and dive back and understand the influence of different elements. So it's very, very rich and very full of samples. And what in OpenSearch, what we've invested in OpenSearch, we've built actually a way to query directly from Vega into the DSL itself. So it's not only a language that supports visualization, but we can also query different data using the DSL. We can register different aspects of the filters. So if we want to interact with different components of the dashboard, we can actually use that directly from Vega. We can register filters, and these filters apply both inwards in the Vega component and outwards for the entire visualization and entire dashboard. So let's go into an example. So we've worked intensively on building a catalog. This catalog covers integrations, which are dashboards, pre-built dashboards for multiple use cases, but also we have created visualizations, and these visualizations are focused on observability. So each component in the observability visualization addresses different parts of questions that are asked. For example, if we want to understand the services, the service map that we have in our system, so this component has a well-defined structure. It shows the nodes as the services. It gives the relationship between nodes, so understanding how services upstream and downstream affect one another. It has the capacity of pressing a service and navigating to the next window. And each of these visualizations that we support in the catalog has a structure that gives the user understanding of what are the queries that we're using. So for example, here we're using 2 queries, and we correlate the information from these 2 queries into one data set. And each one of these visualization, you can try me, you can press the try me button, and it opens in the editor. And you can actually understand what's going on. Thank you. So this example have the central circle, which gives the information about the service. It gives a highlight of what are the average errors, duration, and the amount of requests. And it has a sphere surrounding it, giving a very insight on the amount of errors. So just for example, how this specific visualization can save time and effort. Let's say that I'm searching a table with this information. In the table, I would see that a service name feature flag has the most issues and most error. But when I dive and see that this is not connected to any significant service downstream or upstream in my environment, I can understand that this is something which is not important for me as a site reliability engineer, and I can ignore that. This can only be seen very intuitively in these types of visualization. If I had to go into a quantitative table or graph, it would take much longer to understand. So this is a very immediate and straightforward capability to visualize things which are more complicated than just understanding them from the data itself. So as I mentioned before, OpenSearch works on Vega, connecting Vega inherently into the dashboard. This is something supported from the beginning, but now, more recently, dashboard is transforming more of its components, its building components, to be based on Vega. And the agenda for that is to be, first of all, compliant all around the default component visualization. And second of all, to have a built-in capability to, as we mentioned, it's hard to configure. But once we're using a configurable framework that is supported by nature of configuration, then all across the board we'll eventually have support for this configuration out of the box in the dashboards. So we have these GitHub issues, and feel free to dive into that and ask questions later. Everything is in the roadmap.
Okay. Quick show of hands. How many of you do contribute, contribute to open source? Any contributors here? A few of you do. Okay. So I think it might be worth actually showing. Yeah, it might be worth showing them some of the GitHub issues, things like that, if you're interested, since obviously you're here for the topic. But these are some of the issues you had kind of identified.
So yeah, there is a general notion of moving into a unified mechanism to show all the visualization, and choosing Vega as that mechanism, and that framework is something that is ongoing. So that process is converging from pie charts, from dashboards, from histograms. It is a process ongoing, but it's something that we're very much looking forward into being in a unified manner, using the same component, the same API for all of the visualization components.
All right, so that is our talk.